Here we have an old machine vise. It's far from ideal. Casting's a little warped. The threads aren't great, and I believe the handle may be bent. The other thing as well is, if you have a look on the underside, you can see that this isn't a finished surface here, and I believe that there is it's a high spot on that, which we've just checked with the surface plate. Just pop that on there now, and we'll see how flat we are. You can see we've got a bit of a rock on that, so when we clamp it down, it'll probably change shape a little bit as we draw it flat to the bed or look to distort the bed of the machine. So what I'm going to do now is strip the part down, move the plate out of the way. First thing to do is to remove the plate. We'll inspect some of the parts here so we can see the quality of the finish on some of the running surfaces. As you can see, this isn't too bad on one side. We've got some wear patterns there, a little bit of a dip, so maybe we could flatten this out a little bit. In here we can see we've just got a painted finish on the running slot, so maybe we could skim that. There may be a high spot or a wear spot in the middle. You can see by the marks there that we have got a milled finish, so what we'll attempt to do is to clean that up so that this plate can run on a nice smooth surface. It's quite important for us to keep that parallel so that we can set the tightness of the slide, so that as we move along the slide the tightness will remain constant, because we're only using it to set the gap with these screws, and we have a spring washer. Now the type of these vices is the fact that they don't actually go fully tight. They're just there to hold a bit of tension and a bit of clamping force for this, so that when we close it up it will hold it closed and we won't get too much riding force, because the tendency will be, if a part mounted in the top of the vise, that it'll tend to lift, and that's the thing that we want to be stopping. The other thing now is we can see we've got access to the pin. So I use this device that I made, which came in handy, out of quarter hex brass and a brass, well, it's effectively a brass scriber, so I can use this for picking things out and poking and prodding, and because it's brass it's not going to scratch the surface. I mean, there's always the temptation to drop a scriber down the hole and you end up marking a surface that you didn't want marking. So now we've got that clear, we can remove this jaw. As we go through the strip down and rebuild, there'll be some cleaning involved. Just remove these screws. Take the jaws off, and if we have a look under here, we can see that the part under here, which isn't important, we can leave that as is, because this plate, if it does contact that, we've probably got other problems with the vise. The fact that we're worn out, we've skimmed too much off. Just in terms of appearance, it may be worth just giving it a light skim, but these edges here, you can see that we've got high spots here around the edge and at this end, and the same here and here. In here we've got rough cast material, so we probably aren't making contact with that. and that will affect the loading on the screws and the amount of force we have to use on the screw shaft to actually clamp the vise. And the risk is that if we want to take up the play too much with the screws, we tighten them up too much, this will make for a very, very high load or resistance on this surface and will wear this surface. And the other problem as well is if we get it to a point where it's close enough, we probably find that well, yeah, the jacking force of the screw is just far too high. So I think what we'll do is we'll skim these two surfaces only a small amount. There's quite a bit of float in here, but we only want to just take off their minimum on here, because while we're at this end of the travel we've got a lot of float, but if we look at the distance here that we're moving, we've only got a couple of millimeters there compared to this end, maybe half a millimeter, fractions of a millimeter at this end. So that's what's going to limit this. We don't want to take too much off, else we'll be getting into a position where we need to put plates on there again, and don't really want to get into that. Put that to one side, remove the other jaw. This vise has seen some weather in the past, so there is some rust on here. Now I expect what I may do with that is we'll check it in the lathe, give it a spin to make sure that it runs true, and once we've got it true, I mean, it may be the fact that it's not machined right, is to give it a dip in my favourite, which is white vinegar. That will get rid of all of the rust, and then we'll be into a process of blacking the part again, which I'll probably do using heat. I'm not sure if it's hardened yet. We can maybe check that with a file, but if it is hardened, we want to be careful with the heat treating process, because else we'll be taking ourselves backwards with that one. We could heat it up red hot, dunk it in oil, that'll give us a nice blue coat, and then we can warm it again up to temperature, which may be a blue for us, and then we'll dip it in water, or maybe brine as well, cold brine, just to put some hardness back into it. But I'm hoping that if you get it right, the loading on this will be low anyway, so the wear will be low. Before we get started on this piece, skimming the surface, I've decided to put parallels under this surface, support it on the milling towel in this manner. So I've given those a stone over to remove high spots, and looking at the pattern on there, I don't believe that there is a massive amount of wear or anything that I should be truly concerned about. So I'm going to put two parallels in there and support the piece in the vise this way, probably clamping here and here, skim the two inner slots, and then skim the outer surface, making sure it's flat. It's going to be a fine balance of clamping force, because what I don't want to do is to get the part to bow in that way. So I'll see what I can do with the blocks to best support this, because what I don't want to do is machine a dip into it, although it's probably better than the rock that we've got at the moment. The second job will be to get the verdict gauge onto the milling machine and make sure that the vise is true. Although I'm thinking of that, I'm probably not going to need that for this particular job. Here we are at my Melco milling machine. I've set the vise up on some parallels and clamped down onto it, and I knew I got the DTI out for a perfectly good reason, and what I've done is I've actually clocked the the inside of the slot to make sure that when I machine, I'm running parallel to the part. So now we'll get a cutting tool in there and run the 2 inner slots to start with, where the traveller plate runs, and then we'll look at machining the bed. I'm only planning on taking a very light cut on this, one, because the machine is a very light milling machine, and because of the way that the work is clamped. I've now got a 1/4 inch diameter 4 flute high-speed steel cobalt cutting tool in. I've touched off on the work and backed off by a few thousandths in the x-axis and also in the y-axis. So I'm just clear of the chamfered edge and just clear of the running surface, as we'd call it. I'm going to make a light cut and see how I look, and then I'll cut the other side. I've taken a few light cuts, and they were slightly high at the fixed end of the vise, but that's worked out lovely now. So I'm just going to do the same on the other side and get them to the same height, and then we should look at facing off the bed itself to get rid of that rock, hopefully. Again, I'll take a light cut and then we'll test it on the surface plate. So I've now completed the 2 passes, and I'm quite happy with those. I've run the slider through those as well, the sliding plate, and it seems much smoother now to run over those 2 runners. So now I'm going to proceed with putting in a larger cutter. I think I may be able to get away with a fly cutter, but we'll see how we go. Or failing that, I've got a 42mm insert type end mill, which I may put in, and then I can do the 2 sides in a single pass. So here we are with the setup I'm going to face off with. 42mm indexable cutter, and it's the first tryout of my new draw bolt that I machined out and brazed on a nut. So hopefully that's all going to go well. So I'm going to skim the surfaces now, and we'll be back when we see how it goes. Now, I've just made my final pass on this now on both sides. Both sides are even. So what I'm going to do now is to unclamp the part and check it on the plate, just to make sure that we've got rid of the rock and we've not introduced any bow. One other thing that I did have to do was to move the part across on the table, because I couldn't get to both sides, mainly this side. I couldn't cover this fully when the bed was in fully in the Y direction. So I'm moderately pleased. I should take that off and see how we go, and then decide where we go from there. Just thought I'd show you the drawbar that I made for the collet attachments on the milling machine. So for the nuts, obviously I turned that to a custom size using a rotary table, and quite easy doing 6 flats, especially if you start from a piece of hex bar, because you can just index it in the vise, and away you go. You just take a bit of the dimension off and get to the size of nut you want. What I did want is, rather than use a piece of stud bar, was to actually have a shaft with a plain finish and then a threaded end. So just in terms of the way it looks, I think just been through the process of realigning the chuck, so we're better than 5 thousandths of a millimetre accuracy on the alignment now. I'm just going to chuck up the jaw here, because we have this face. I'll give a light rub with a stone just to make sure we've got no burrs on there or lumps that might change the or upset the position from a right angle, and then we'll look at running a skim over these surfaces. I mean, that looks to be about 1/2 inch, so we'll go with a 1/2 inch cutter over these two surfaces, and then I'll have a think about that one, because we may be just taking on more work than we need to. I decided to machine both the rubbing faces or sliding surfaces on the bottom of the movable jaw, and also the section in between, just to tidy it up. Although it did release or show a couple of occlusions in the casting, which is probably not fantastic, but it won't affect it for what it needs to do. Here we are at the Myford lathe, and I've mounted the spindle in the vise, and I've got it turning over gently, and we can see that the shaft does have a wobble. We're actually gripped in at the nut end, so I think the machining on that chamfer leading up could probably do with tidying up a bit, but the main concern is us relieving this wobble. So somewhere in the shaft there's a bend. I've made up some brass shim, so I may work up and down the threaded part of the section in the jaw just to see where the bending moment starts, and then start working from there. Back at the lathe now, and I've turned the part round in the lathe, and we'll just give it a spin. Now I think there might still be a slight ripple in the thread, but the thing that really causes the bother is the fact that the end isn't really machined that well, so I'm not sure whether that's bent at the moment. I mean, looking at it now, it looks as if there's definitely some concentricity issues, and maybe a bit of bends and dating action going on there. So what I'll do is I'll chuck the part up close to the thread and give it a run and see how we look. Well, here we are after some deliberation, a lot of effort, and a way of doing things. What you can see here is the red marks. That isn't actually me bleeding over this, but what I've been doing is I've been spinning the part and then just touching off with this, catching the high spots. So although I've got a variable speed control unit, I can slow the lathe right the way down, but still it's not enough to see where the spots are. So just touching off like this gives me a good mark, and then I can either try and press the part in the lathe, or take it over to the bench vise and give it a bit of a lever as to where I think it requires the moment. I did use a parallel just to check the thread and get that straight, but then I had some problems with the concentricity, and the main issue was the fact that the center drill in the end was off center, and everything is hinged off of that. So now I've, as you can see, that's running nice and true now. Thread's probably as good as I'm going to get it. I'm quite happy with that. I thought that this chamfer might require some attention, but you can see we've got a very slight shimmy there, so that's probably not worth touching up if we're turning it by hand. Whereas if we look at the other end, that's going to need a face off and a bit of treatment. So yeah, that'll be the next operation, and then I'll give it a clean up and polish the end up, and then we'll see how we look. Probably onto the next part. Here we are. We're looking at the results of all the work. I think all the machining is done. Yeah, we've only stoned this surface, so I've used an oil stone and just taken off any high spots. A bit of a rub on the corner there. Not much else done on the top side. Most of the work is underneath, so you can see we've got these two milled surfaces which just look a whole lot better now. And also the slideways in here that were also paint finished, they had been milled but painted over, but the milling wasn't quite as fine as we got here, so that's that part. Screws just had a general clean. Most of the work I think was probably in this spindle, in terms of straightening the spindle and then finishing it off so we're actually square on the end. And I've polished up these parts, although when I run it through the heat treat process it might not look quite so good. What I'm going to do is warm that up and then quench it in oil and give it a black look. The jaws of again, these have just been stoned to take off any high spots, so they're better than they were. Nothing much on the surface here. A little bit of a nick on the corner there that's been dressed. Another one with a couple of odd high spots and a bit of a trim. We've had a bit of a nick there out of that. I'm not sure when that happened. It's been there some time though. The plate that fits underneath, again, this is okay in terms of contact. I've lapped it and we've got the areas. They're not too bad there. It's not brilliant, but in terms of the whole piece, it was one of the better pieces. And here we have the movable jaw. Again, only one job to do on this, and that was to get the unit square, so that what we could do is machine these surfaces, because these were they hadn't even been milled, they were rough cast. I'd had to go addressing them with a file, but then I thought, well, no, we need to mill these. So they're milled. I'd used a 1/2-inch cutter in the end, but it wasn't quite enough just to make one pass on that. And then as I had it set up, I decided to just tidy this surface up. I'm not going to repaint it, but I will leave it lightly oiled. All the holes have had a countersink through them just to put them back as they should be. As you can see, we've got some occlusions there, but again, it's tidier than it was. I could paint it if I felt like it, but I think I'll get the parts blued up and then we'll put the vise back together. I've just come in from heat treating my parts. We've treated this, but I didn't heat it too much. I just heated it enough to take the colour on. So we've got a colour on there, and that takes away the silveriness that we did have. So it now looks a lot more even. The parts come out quite nice. I've just put the pin back in, and all the parts have been lightly oiled. Turn this over without it falling to bits. That's our underside, and I shall continue fitting the other parts. We need to fit the clamp on there and the 2 screws and the 2 jaws, and then we'll test the quality of the fit. And one of the things I do like about oil bluing process is the fact that the parts come out with a lovely patina, and also lightly oiled and cleaned by the heat. So a winner there. I'll get these bits assembled, and then we'll come back and have a look at the finished vise. This is one thing I thought it was probably important to show, is the adjustment of the screws. Now, after much trial and error, I'm thinking that the best way is just to tighten these up all the way. So then we clamp the part fully. If we just go in and tighten them up gently a half a turn, we don't really have a point of reference. So by doing this, we set that. So that's set now. The gaps are looking fairly even on both sides, so I'm happy that the part is square. So what I'm going to do is just back these off half a turn each. And hopefully that should be about right. There may be some cause for adjustment. There we go. There's a tiny amount of play in there, but it's a much improved vise from where we started. So jaws close up okay. Yeah, and the handle turns. So that's a much easier turn, as with all things, when you put them back together, there'll be a period of bedding in. So it's just to keep an eye on the adjustment as we run the equipment in. Just keep an eye on that, and then make sure that we keep it adjusted. The thing we don't want is for it to become poorly adjusted, and then we tighten up on it and things go wrong, or we have an accident on our machine because the equipment isn't working right. One other thing just to test is the bed. So I'll just bring the plate over, pop that on there, so we fixed the problem underneath. Plus it does look like a finished vise now, so things are much better there. So I'll be looking forward to using this and having a second drill vise.